The most powerful telescope ever built found galaxies that shouldn't exist, detected water on a planet 1,000 light-years away, and looked back to the dawn of the universe. The James Webb Space Telescope has been operational for just a few years, and it's already breaking our understanding of reality. Here are 7 discoveries that changed everything. JWST found galaxies in the early universe that are way too massive and too mature for their age. These galaxies formed less than 500 million years after the Big Bang, yet some of them contain as many stars as our Milky Way. According to our current models of cosmology, there simply wasn't enough time for galaxies that large to form. Scientists call this the impossible galaxy problem, and it might mean we need to rewrite how we think galaxy formation works. Some researchers are even questioning whether the Big Bang timeline itself needs adjusting. JWST detected water vapor in the atmosphere of a planet called WASP-96b, a gas giant about 1,150 light-years away. This wasn't just a hint of water. The telescope produced a detailed chemical fingerprint showing exactly what's in the atmosphere. While this planet is too hot for life, the technique proves JWST can analyze the atmospheres of distant worlds. The next step is pointing it at smaller, rocky planets in the habitable zones of their stars, looking for the chemical signatures of life. The pillars of creation are towering columns of gas and dust where new stars are born. We've seen them before with Hubble, but JWST's infrared vision pierced through the dust and revealed something Hubble couldn't see. The pillars are packed with newly forming stars, visible as bright red points of light embedded in the gas. JWST also detected molecules called polycyclic aromatic hydrocarbons, the carbon building blocks of life, floating in the clouds. The image is one of the most detailed views of star formation ever captured. JWST captured the clearest image of Neptune's rings since Voyager 2 flew by in 1989. The rings are so faint and dusty that they're almost impossible to see from Earth. But JWST's infrared camera picked them up clearly, along with several of Neptune's moons and even storm systems in its atmosphere. The images also revealed something unexpected, a bright cloud at Neptune's north pole that nobody knew existed. JWST spotted a single star nicknamed Earendel, whose light has traveled 12.9 billion years to reach us. That means we're seeing this star as it was when the universe was only about 900 million years old. Earendel is at least 50 times the mass of our Sun and millions of times brighter. It's the most distant single star ever detected. Before JWST, we could only see entire galaxies at that distance. Now we can resolve individual stars in the early universe. JWST turned its infrared eye on Mars and detected carbon dioxide in the planet's atmosphere with unprecedented precision. But more interestingly, it found evidence of carbon dioxide clouds high in the Martian atmosphere, something we've never observed before. The telescope also mapped the distribution of water vapor across the planet's surface and atmosphere, providing data that could help future Mars missions understand the planet's climate and where water might be hiding. JWST can't see dark matter directly because dark matter doesn't interact with light. But it can see the effects of dark matter through gravitational lensing. When massive amounts of dark matter sit between us and distant galaxies, their gravity bends and magnifies the light behind them. JWST used this effect to map the distribution of dark matter in galaxy clusters with precision